Good morning, class. I'm Mr. Caldwell. I'm excited to be your teacher for our algebra unit on quadratic equations. Before we start, could we go around and introduce ourselves?
I'll go first. My name is Codette. My family came here from the Helix Nebula before it exploded.
I am Wendigo. I come from the land of the great waters.
I'm Ruby. I take the bus here from the Werewolf District downtown.
Who's next?
I guess I'm next. My name's Bones. I just came here from the graveyard next door.
I am called Killer Robot. I escaped from the experimental division of the Zorgax Corporation.
Killer Robot, is there a nickname we could use for you?
Affirmative. My model number is V9.
Perfect, V9. And last but not least, you and back?
As you probably know, I am Tom Dracula. My family founded this school.
It's nice to meet everyone. Congratulations to all of you on getting this far in algebra. Now, quadratic equations are not an easy unit, but we're a team. We can do this. So let's get started. What is a quadratic equation? Remember that an equation is just a math statement with an equal sign. 2 plus 2 is not an equation, but 2 plus 2 equals 4 is an equation because it has an equals in it.
Mr. Caldwell, we're not babies. This is algebra class, not 2 plus 2 equals 4 class.
You're right, Tom. In algebra, we learn how to solve equations with a variable replacing one of the numbers. Instead of 2 plus 2 equals 4, in algebra, we get x plus 2 equals 4. Then we learn to solve equations with two variables, like x plus 2 equals y. We call them linear equations because when we graph them, they make a line. Now we're taking it to the next level by learning about quadratic equations. The quad part of the word quadratic means square, and that's what makes a quadratic equation different from the equations we just saw. It adds an x squared. If we add an x squared to the equation we already have on the board and make it x squared plus x plus 2 equals y, then we just turned a linear equation into a quadratic equation. It's that simple. Quadratic equations are just equations where the variable is squared. So, is this a quadratic equation or a linear equation?
It has an x squared, so it's a quadratic equation, right?
Good, Codette. Here's a trickier one. Y equals 3x plus x squared minus 5. Is that a quadratic equation?
I'm definitely not sure.
Well, it still has an x squared in it, so isn't it still a quadratic equation?
That's right, Ruby. It's a quadratic. Let's do one more. Y equals 5x minus 10.
There are x's, but no x squareds. Therefore, it cannot be a quadratic equation. Correct, teacher?
Good, Wendigo. This is just a linear equation, not a quadratic equation. Now that we know what a quadratic equation is, let's talk about its graph. Linear equations, like y equals x plus 2, graph as lines, like this. But quadratic equations have an x squared in them, so they're probably not going to graph the same way as linear equations. In fact, they look pretty different. Here's the graph of y equals x squared plus 2. Pretty cool, right? This U-shaped curve of y equals x squared plus 2 looks very different from the line of y equals plain old x plus 2. We call this curvy U-shape a parabola. Parabolas are the trademark shape of quadratic equations. The reason quadratic equations make this shape is because of the x squared we've been talking about. Quadratic equations always have an x squared in them. And what happens when you square a number?
Oh, I think I know.
Good, Codette, but let's hear from someone new. How about you, V9?
I am 0% sure of the answer.
What happens when we square a number?
It gets much bigger.
Well done, Tom. Look how fast the curve of the parabola rises compared to a line. The line keeps rising at the same rate, but the parabola is rising much faster. That's because of the x squared. And there's something else that the x squared in a quadratic equation does. Why does a parabola turn around and make this U shape? A line always keeps going in the same direction, but a parabola turns around like this. How does the x squared in a quadratic equation make it do this? I'll give you a hint. When you square a negative number, what do you get? For example, what is negative 2 times negative 2?
Positive 4.
And what is negative 3 times negative 3?
Positive 9.
So, anytime we square a negative number, a negative times a negative gives us a positive number. Our quadratic equation has an x squared in it, so anytime we plug in a negative number for x, it gives us a positive answer. In fact, it gives us the same positive answer as when we plugged in the positive version of that same number. Negative 2 squared is 4. Positive 2 squared is 4. Negative 3 squared is 9. Positive 3 squared is 9. So, if we plug in negative numbers for x, we get the same answers as if they had been positive. That's why the negative and positive sides of the parabola are mirror images of each other, because of the x squared. All quadratic equations have an x squared in them, and the x squared is why a parabola turns around and bends backward. Now, one thing you should know before we move on is that parabolas can also be like this, where they've been flipped upside down, rainbow-shaped instead of U-shaped. So let's test ourselves. I'll show you a graph, and you tell me if it's the graph of a linear equation or a quadratic equation.
I think maybe it's a parabola, so I guess it's from a quadratic equation?
Good, Bones. What about this one?
According to my calculations, this is still a parabola, no matter which way it opens. Therefore, it is the graph made by a quadratic equation, not a linear equation.
Excellent, B9. A parabola can be a U shape or a rainbow shape. We can turn that frown upside down, and either way, it's still a parabola. So these are the graphs of quadratic equations, not linear equations. But what about this one?
I believe that is simply a line, teacher. So, it is the graph made by a linear equation, not a quadratic equation.
Well done today, class. Let's quickly review what we've learned. A quadratic equation is different from the kind of equations we've seen in algebra before, because quadratic equations have an x squared in them, not just a plain old x. All of these are quadratic equations. We can have more than one x squared. We can have no plain old x's. We can have the x squared anywhere in the equation. If there's at least an x squared in there somewhere, no matter whether it's positive or negative, we have a quadratic equation. Later in math, you might learn about equations with even higher powers of x, like x to the third, or x to the fourth, but we don't need to worry about that right now. If you have an equation where the variable is squared, you have a quadratic equation. And the shape that quadratic equations make when we graph them are called parabolas, the U-shaped curves that can either face up or down. As soon as we see a parabola instead of a line, we know we're dealing with a quadratic equation instead of a linear equation. That's all for today's lesson. Good work, class. Make sure you do your homework, and I'll see you next time.